So basically you'll learn what is density and mass. Volume you guys have been pretty familiar with from the past 2 lessons. And then real world problems using density. And the reason why I really like this lesson is because I dealt with it all through college. So I feel like this really does have a lot of real world applications. All right, so density and mass, so a couple of things to highlight, some new words. We have density is a ratio of mass to area or volume. So that formula, if you want to write it up here, density equals mass divided by volume. All right, so like density, for example, can be expressed in grams per centimeters cubed. So mass, like you can weigh something in grams, and then like we learned in volume, volume is always cubed, right? So that's usually like if I can't remember D equals M over V, I usually remember like, oh, well, they always use these units most of the time. So it's mass over volume. All right, mass specifically is how much matter is in an object. People confuse it with weight because, you know, we measure things in grams, which is weight or like pounds or things like that. But it's how much matter is in an object. So if I said like there's 9 students in class, that is, that would be a mass unit. So it doesn't just have to be weight, it could be like number of people in an area. Can be represented as people, things, heat, etc. So we have a subway car is full of people, which makes up the mass of the car, right? So the car can only hold so many people and objects. That'll be the volume of the car, like 20 people per, maybe not 20 people, 1 person per cubic meter or something like that. And that would be your density, is putting those two together. Here's an image below, shows 2 cups containing pretzels. The cup on the right is clearly more full than the cup on the left, so more full than that cup. This means the cup on the right has a higher density than the cup on the left. So when I have more stuff filled up in something, whether it's more people in a classroom or something along those lines, that would be a higher density. So like during the school year, I normally don't have 10 students. So during the normal school year, I have like 30 per class. So that would be a higher density than this classroom, for example. Questions on any of the definitions? All right. So example 1, an average classroom measures 20 by 30 by 10 feet. If the maximum capacity of a room this size is 45 students, what's the density of this classroom? So if you want to break this down into steps, you can kind of write this down. First thing you would do is determine whether you're solving. So determine whether you are solving, oops, I spelled that wrong. All right, determine whether you are solving for D, M, or V, right? Because our formula is usually density equals mass over volume. So what am I solving for? What does it say to solve for? Good. So what is the density of the classroom? That means I should have stuff for the mass and the volume. All right. I feel like math still might be hard for you guys to understand. Let's do volume because we've done that for the past couple of days. So how can I find the volume of the classroom?
Wouldn't the classroom be like a square so you could do the formula for that?
Good. So more like rectangular shape, like this one. So length times width times height would be what you use, and they do provide that here. So to find my volume, I would do 20 times 30 times 10,
6,000.
which equals 6,000. And that is for my volume, right? So that has to go in this portion of my fraction down here. Everyone with me so far? So in order to find the density, I need to put the mass and the volume in that fraction. Volume is length times width times height, which is 6,000. So we're putting that at the bottom. What is the mass in this problem?
Wouldn't it be the 45 students?
Good, it is the 45 students. So yeah, you might think of it as weight sometimes, like mass and weight, but it can also be like people, things, right? So we have students per, or actually I'll put a slash, we can get used to seeing those. So we have students per cubic foot or foot cube. All right, now put in your calculator 45 divided by 2,000 or 6,000, sorry. 45 divided by 6,000.
It's 0.0075.
Good. So then our answer for the density is 0.0075 students per cubic foot. And that is all you're doing there. I'll put a normal equal sign because it's not an approximation. All right, does that make sense? And notice the units are also mass over volume, so whatever your mass represents, which right now it represents students, over the units for your volume, which is whatever units you were using cubed. All right, that's how you write your answer. Questions? All right, so then let's look at example 2. I'll wait just a little bit. All right, so example 2 says if the maximum density of a restaurant is 0.075 people per cubic foot, and the volume of the restaurant is 2,000 feet cubed, what is the maximum number of people that can occupy the restaurant at any given time? All right, keep in mind, this is the formula you're using, density equals mass over volume. Now figure out what you're solving for. Are you solving for D, M, or V? So kind of go through the problem.
Are you solving for mass?
We are solving for mass, good. Because if you go through the problem, it tells us what the density is, right? It tells us that D equals 0.075 people per cubic foot. And the volume of the restaurant, it also tells us. So M is the one that we don't know. All right, so plug it into your formula. 0.075 equals mass over 2,000.
When I put in, are you supposed to put in like 0.075 over 2,000?
No, because, well, we'll show you how to solve for M in the next step, but you first set it up like this. So it has to look like the original formula first. All right, Another indicator too is, for what we're solving for, is the units that they use for density. It says people per cubic foot. On the bottom, volume is in cubic feet. Mass is people, and it's asking what's the maximum number of people. Right, so it's another way you could figure out what you're solving for. So now that you have it set up, you can solve for n. So a little bit of algebra. Remember when we did like the trig functions? All right, it's the same steps for when you're isolating a variable. So what can I do to get the n by itself?
You subtract 2,000.
Is subtracting the opposite of dividing.
No, you multiply.
Good. So you do the opposite of dividing, which is multiplying. So multiply it on the right side to cancel it out. And whatever you do to one side, you have to do to the other side. So m equals 2,000 times 0.075. So don't say it out loud yet. So what's the maximum number of people that can occupy the restaurant? You can say it now.
150.
150. All right, that's what I get for multiplying it. So you could say 150 people if you want to put units. All right, if it gave you a decimal for some reason, you can't have like a fraction of a person, so round down. All right, if it gave me 150.9, well, I can't have 0.9 of a person, right? So it would just be 150 still. Questions? All right, the next one says you try, but we'll do this one together, number 1. And then you guys will try number 2. All right, so the population density of Giantville is 16 giants per acre. Exactly 800 giants live in Giantsville. How many acres is Giantville? All right, so again, density equals mass divided by volume. Am I solving for D, M, or V?
Is it B?
We are solving for B, good. So we practiced solving for D, we practiced solving for M, now we're solving for V. So you could have figured that out by going through the problem. It says that the density is 16 giants per acre. So V is going to be 16. And then exactly 800 giants, so 800 people, things, whatever. That's what our M is. Because M can be people, things, whatever, weight. So we have D, M, V, we don't know. So plug that into your formula. So we have 16 equal to 800 divided by V. So all we did is plug it in so far. Also notice the units for density are giants per acre. So the top is giants, the bottom is acre, so that matches up. Question so far? All right, now we're going to solve for V. Now, just like when we did trig ratios and stuff, when your unknown is in the bottom of your fraction, it's a little more challenging to isolate it, right? So what do I do to isolate it, or to begin isolating it?
You'd multiply by 800.
I would not multiply by 800. Because if I do that, then I get 640,000 on the right side, so that doesn't cancel anything out, right? So what would I do instead?
Subtract or divide.
No,
Add.
no. It would be easier to isolate the v if it was not in the denominator. So what I can do is I could multiply each side by v, which I know seems counterproductive when we're trying to isolate v, but you'll see why in a second. Because if I can get the fraction to cancel out on the right side, on the left I have 16 times v equal to 800, and now it's easier to isolate the v. Does that make sense? All right, if not, just take really good notes on this problem so that you can follow the same procedure on the quiz or the practice. All right, what's the last step in isolating v? So do the opposite of what's being done. What's opposite of multiplying by 16? So we're going to divide by 16. So do that on each side. On the left side, the 16s cancel. And your volume is whatever 800 divided by 16 is.
50.
Okay, that sounds right. And it is. 800 divided by 16 is 50. And the units are going to be similar to what we had before, acres. All right, because density is shown as giants per acre. So my volume would be 50 acres. Questions? Does that make sense? Maybe. All right, well, the next one you'll try on your own. So the one that's on the right of the screen, try it on your own paper. I'll come around and make sure you guys are getting a good start. But that's really all for the example problems. So try the next one, and then you'll have time to do your practice afterwards. So the density of a fish tank is 0.5 fish per cubic foot, and the volume of the tank is 12 feet cubed. What's the number of fish in the tank? So are you solving for D, M, or V?
Mass.
We're solving for mass, good. So fill in what you do have. It tells us this is the density, so density is 0.5 fish per cubic foot. And then it tells us this is the volume. So the volume is 12 feet cubed, mass we don't know, and plug it into your formula. So we have 0.5 equals mass divided by 12. Keep in mind the units that they gave us for the density is fish per cubic foot, which makes sense because it's asking us the number of fish that we're missing, so it makes sense that we're solving for mass. Now, how can I get the M by itself?
You multiply it by 12.
Good, multiply by 12 on each side. That's how you can get the denominator to cancel out in this fraction. And then what you do on one side, do to the other side to keep it equal. N is now by itself. It's 12 times 0.5, which is
6.
6. All right, and then the units would be fish. All right, if you got that on your first try, good job. If not, just keep practicing. You guys have the 8.04 worksheet. If not, there's 2 more on the back table. I'll put the timer on for like 15 minutes, and then we'll move on to the other thing that we're doing today. All right, so if you have questions, let me know, and then you'll turn it into the basket when you are finished.